Dear students, once again we are begin with topic number 3, and in that we are going to start with the sky wave propagation. Students, already we are aware that the region above the Earth's surface at about 10 km is known as a tropospheric region, where the atmosphere is very calm and quiet. It is well mixed, air stratifies, temperature and density decreases, and there, due to the aspect of super refraction and duct propagation, the signal is carried away between transmitting antenna and receiving antenna beyond the line of sight in the shadow zone. But if the transmitting power becomes much more, and if the frequency transmitted by the transmitter is very large, then there are the electromagnetic radiation which crosses the troposphere and reaches the height around about 60 to 300 km above the Earth's surface. So at that particular height, space wave, ground waves and even tropospheric waves are unable to carry the signal between transmitting antenna and that of receiving antenna. Therefore, those radiations which crosses the tropospheric region and reaches to the ionospheric layer at the height of 60 to 300 km above the Earth's surface, the layer is known as ionospheric layer. And from that ionospheric layer, if the electromagnetic radiations undergo reflection, provided the conditions are favorable for that, then they will carry the signal for a large distance between transmitting and receiving antenna. Those waves are known as the sky waves. Friends, today we are going to study the propagation by means of the sky waves. To begin with to study the propagation by means of a sky wave, we can say that the electromagnetic radiation having the high frequency and high power of the transmitter, which are radiated beyond the horizon above the troposphere, unable to reflect towards the Earth. So that's why those reaches to the upper layer of the atmosphere, and that is known as ionization layer. This upper layer is very close to the sun. From the sun, the ultraviolet radiations are emitted. These ultraviolet radiations ionizes the gas molecules in the form of positive ions, and the layers of ions are formulated. And if the conditions are favorable within that particular layer so formulated, known as ionospheric region, then so reached electromagnetic radiation reflects towards the Earth. These reflected electromagnetic radiation and used for the communication for a long distance between transmitting and receiving antenna are known as the sky waves. And thus the electromagnetic radiation that crosses the troposphere beyond the horizon reaches to the ionospheric layer, and if the conditions are favorable for the reflection, then they will be reflected towards the Earth, and after that they carry the signal between transmitting and receiving antenna so as to cover several thousands of kilometers. Those radiations we can call it as the propagation by means of the sky waves. But the reflection of these waves depends upon several factors in the ionospheric region. These waves carry the signal at broadcast range only during the night time, but during daytime they are absent or they are weak. Increase in frequency of the transmitter makes the reflection of sky wave very strong. within the frequency range of 10 megahertz to 30 megahertz, the reflection is very strong and they can be used to cover a distance of the order of several thousands of kilometers. Further increase in frequency makes the sky wave to escape the ionospheric layer and they are going to lost in a space. So lost waves in a space are going to act as a microwave and can be used for the satellite communication. The sky waves are useful for long distance communication in a frequency range almost all 3 megahertz to 300 megahertz. The signal received by these waves is not stable, but due to changes in why not stable? Because the condition of ionosphere changes from time to time, day to day, season to season, and also year to year. So that's why the condition of ionosphere is changing. Hence, the sky wave signal is not stable within that particular range. Friends, these conditions are made favorable only because of different types of the ionospheric layers which are going to be existing in the ionosphere. Now we are going to study what are the different types of ionospheric layers, how those are going to get formulated. As we are aware that at the height above the Earth's surface 60 km to 300 km atmosphere, which is very close to the sun radiates different types of light radiations that contains one of the light radiation known as ultraviolet radiations. The intensity of these ultraviolet radiation is very large, and these intense ultraviolet radiations, while traveling towards the earth, when they reaches to height up to 60 km or 300 km above the earth's surface, they will undergo to produce the ionization of the gas molecules as a positive ions and negative electrons with the high intensities, and these high densities ions are distributed according to the heights of the different layers in the ionospheric region. These layers are D, E and F according to the order of height. D layer is very close to the Earth's surface at about 50 to 90 km, which exists during daytime only. During night time, D layer is absent. During daytime, F layer splits into two. One is F1 at a height of 200 km and another is F2 at the height of 350 km. But during night time, F1 and F2 merge together to form F layer at the height of 300 km. The ionization density of E layer is governed by ultraviolet rays and it decay uniformly with time during night time. During night time, D layer is absent. Especially during night time, there exists a cloudy sporadic D layer at a height around about 90 to 30 km. Sporadic E layer, it will produce a very strong reflection for the propagation of the sky waves. So these layers are represented in this particular figure where the density of the ions is distributed with the height during daytime as well as during the night time. During daytime, at a height around about 50 to 90 kilometer, there exists a D layer. Around at the height of 100 kilometer, 120 kilometer, there exists the E layer. F1 layer is located at 200 kilometer. F2 layer is located at about 350 kilometer. But during night time, if you look at D layer is absent. But at a height about 90 to 130 kilometer, the sporadic E layer is located, which is a cloudy region. It produces a very strong reflection to create a sky waves. During night time, F1 and F2 layers are going to merge to get only a F layer. So these are the ways by means upon which how the different ionized layers are going to be generated in atmosphere above 60 kilometer to 300 kilometer, and if the transmitter transmits the radiations, electromagnetic radiations with the frequency in between 3 megahertz to 30 megahertz, they reaches to the ionospheric layers, and if the conditions are favorable in the sense that conditions of the ionosphere is changing from day to day, time to time, season to season and year to year. Due to this aspect, if the conditions are favorable, they will be reflected from ionospheric layer and they can be used as a sky wave to carry the signal for a long distance, that is several thousands of kilometers between transmitting and receiving antenna, which are located on the Earth's surface. Friends, that's what we can call it as. It is the formation of different ionized layer and also how the sky waves are responsible to carry the signals provided the conditions are favorable in the ionospheric layer. That's all about the sky wave communication. Next time we will go for next aspect of the same topic.